Well, good afternoon, everybody. Thanks for coming to listen to us talk about analyzing data streams in real time with Amazon Kinesis. So I'm Alan McGinnis. I am a solutions architect here at AWS, and I work primarily with customers in the streaming data space. So I work with customers that are doing eventing, streaming their data logs. So a lot of what we'll discuss today is quite often practiced by many of the customers that I work with, and hopefully you guys can learn a little bit about it as well. And with me today, later on, who will speak specifically about what they're doing at Singha in this space is Milan Brambat. So he'll come up and kind of dive deep into what they're doing in a specific use case at Singha. So before we get into some of the details, let's just quickly talk about why stream your data. And it really comes down to timely decisions. So data is being generated continuously, right? I think we all know that. Think about even the simplest kind of multi-tier website. I've got a website out there with a database behind it, and I'm just serving up some data. Maybe my users are doing something with that data. In a traditional world, if you think back maybe just a few years ago, we really didn't do much with the data that we got in that interaction until maybe tonight, right? We ran a batch process against that data to get some insights into what's going on. Well, if you think about that data and when it was generated as soon as perhaps that user clicked on the website. But if I don't do anything with that data until tonight or tomorrow or next week, I lose a lot of value. There's something I can learn from the fact that a user did something in my app or on my website, immediately after it happened. So we like to talk about sort of the value of data and how it diminishes over time. So it's kind of an important concept to think about when you're thinking about streaming data, because today it's fairly straightforward to capture the data and do something with it, and that's what we'll discuss. So stream new data in seconds so that you can get actionable insights quickly. So ingest video. So I'm not going to talk a lot about video today, but I'll touch on it very briefly. Video, right, is just data. It's data that's streaming that you can capture and do some insights, make some insights out of that data. Primarily, we're going to talk about the sort of classic data today, things like Clickstream or game events. But as soon as it's generated, do something with it. Process it on the fly, and in real time, get some insights out of it by applying, calculating some analytics, doing some machine learning. So it's very important, helps you get insights into what your customers are doing in real time with the data. So some of the most common streaming use cases that we see, again, the camera on the left is a good example of a video example. But the rest of the four here are more common, which is the typical data streaming. So things like industrial automation. I've got devices in a factory. They're always generating data. Log analytics. This by far and away is probably the most common use case that I see working with customers in this space is applications are continuously creating logs. Doing something with those logs as soon as they're created, very important. Using streaming data to feed data lakes. And I'll get into a specific example about that here in a moment. Then IoT device monitoring. So this is sort of similar to the industrial automation example, but everything today is becoming connected. And all of those devices are sending data somewhere. So let's do something with that as soon as it gets created. So in the AWS world, what are some of the services that help you collect and analyze this streaming data? We have a collection of services in the Amazon Kinesis space. From left to right, we have data streams, data Firehose, data analytics, and video streams. Now, I'm not going to talk anymore about video streams, but it was introduced at our conference, our reInvent conference in November of last year. So that's why there's a few slides in here that discuss a little bit about video, but the bulk of the day will talk about data. So when you think about Kinesis data streams or data analytics or data Firehose, we're talking about streaming data, processing it with some tool, and then writing the results of that process somewhere else so that I can get some insights into it. So if you look at this slide, don't worry too much about the details, but we look at some data from the left. Kinesis data streams as the primary ingestion tool. And then with Kinesis data streams, you can choose to use any number of stream processing solutions to get the insights into the data. So here we show Spark running on EMR, your own code that you can write on EC2 using some libraries and tools that we've provided. You can use Lambda to process that data in real time. Or you can use Kinesis Data Analytics to get some real-time insights into that by writing some standard SQL. And then from the output of analytics, you can send it to any number of downstream sources or destinations such as S3, Redshift, Elasticsearch, and Splunk via Kinesis Data Firehose. So this is one example of kind of a typical data flow that you might see. And all of these services, Kinesis Streams, Firehose, and Analytics, give you the ability to do that in real time. They're fully managed, so there's no EC2 instances that you need to manage under the covers. They're fully managed services. They're scalable. So Firehose and Analytics do some amount of scaling automatically. And with Kinesis Streams, you can scale very simply by adding additional capacity. We call them shards to the stream. And they're very cost effective. So the pricing model in these services is generally based on how much data you put into the actual service. So I'm not going to get into much detail on the cost component, but they're basically, the more you use the services, the more they cost, much like many of the AWS services. A quick show of hands, maybe. How many folks are already streaming data in your environment today, doing some amount of streaming and processing? Hard to see. OK, it's about maybe a third. So cool. So some of this is probably old hat to you, and some of this, maybe for some of you, is new. Let's talk a little bit about a couple of use cases. So Clickstream analysis, this is something that typically in years past, and not even that far ago, and I'm sure many organizations are still doing this in a batch process today. Clickstream, click events are being created, being stored in the local log file, maybe it's an Apache Access log or something, and we run a job on a daily basis that takes the data off of those servers, puts them into a data warehouse, and then we run a batch process on a nightly basis to get some insights out of it. That's all well and good, but like I discussed a moment ago, you lose some of the value in that data if you don't process it until much later. So by streaming those Clickstream events in real time through like a Firehose on the front end, so collect this data, do some analysis with it, do some aggregations in real time. So how many times has this page been viewed in the past 5 minutes, right? If I can get that as soon as that 5-minute window closed, I learned a lot about what's going on in my application. So that's one example of doing real-time analysis. Calculating real-time analytics. So this example talks about analyzing streaming social media data. It can be any kind of data that's relevant to your application. So calculating KPIs, whatever metrics are important to your business, why wait until a batch process to figure out what that means? So I've worked with one customer. They're in the e-commerce space, and they sell products on their website, and they want to know every hour what is moving, what are people looking at, and this is not Amazon, by the way. This is a different e-commerce company, but what are people looking at on the website? What's a popular product? They used to do this on a daily basis, and they wanted to apply some marketing to their system. They wanted to say, well, things aren't this particular product I just promoted. I'd really like to know how well that promotion is working, and I don't want to wait until tomorrow to do that. So they've implemented a solution similar to this where they're collecting the metrics off of their e-commerce website, and they are building a dashboard that's based on the real-time metrics that are created on the fly every hour. So that's their KPI is looking at the metrics related to the products that are selling well or not well on their website. And they're building dashboards around that in real time as opposed to building something on the back end. IoT stream processing. So this is a very common pattern that we're seeing too. There's, like I mentioned a moment ago, there's so many devices these days that are generating data continuously. Let's collect that data and build some alarms around it. So in this one, right, we've got a tractor that's it's sending metrics about what it's doing in the field. And then it can recognize when parts, and some of this, of course, machine learning is built into the tractor, but it's learning a little bit about what's going on, maintenance periods, and it's sending data to the back end, and it can alert technicians in real time when a part is about to fail, and they can go and reorder those parts. So all of those three examples if we look at the, go back, can I go back? Right, they all have Kinesis Analytics in the middle. So getting some of those insights into the data is pretty straightforward when you're using a service like Kinesis Analytics. So maybe a quick show of hands. How many folks here have looked at specifically the Kinesis Data Analytics tool and have used some SQL to get some insights out of your streaming data? Okay, so it's pretty smaller set than a moment ago. And that's good. So I think today we're going to focus a little bit about Kinesis Data Analytics. And Milan will talk a little bit about specifically how they've used this tool to get some insights into their data. So I'm going to dive into a few of the key concepts in Kinesis Analytics. And then, like I said, Milan will take over from there. So as I mentioned, it's all about the pace of data. Things like hourly server logs, weekly or monthly bills, these are all kind of batch things. Think about your credit card, right? A batch process, once a month you get a statement. All the transactions you made are batched up on a monthly basis, and then you pay for it. Think about the stream processing. Imagine if you didn't hear from your credit card company about a potential fraud transaction until the end of the month, right? That would be pretty bad. So what a lot of credit card companies do is they'll stream that data, and then they have a fraud detection algorithm that looks at every transaction being made on your card, and they can determine if there's fraud in real time, and that's why you might get a text or a phone call from your credit card company. So a good example there of like a batch process and a real-time process, and how we can really benefit, and how your customers can benefit from real-time. So Kinesis Analytics, today the sources for your Kinesis Data Analytics application can be a Kinesis Data Stream or a Kinesis Data Firehose. And then you write your SQL to process the streaming data that's coming from one of those two streaming services. And then you output what you learn based on your SQL. So typical pattern, data producer, a streaming service like Amazon Kinesis, and then a data consumer. And the Kinesis Analytics application, that is your consumer, right? You have a data producer. In this case, it's showing a mobile client sending data to a Kinesis data stream. And then your Kinesis Analytics application will listen to that streaming data, and then depending on the code that you write in your SQL, you'll get some insights out of the data. So it's typically a three-step process. Basically, you connect to your streaming source, you write your SQL, and then you continuously deliver those SQL results. And I'll get into a bit more detail about the SQL here in a moment. One of the nice features, too, that you can also do with Kinesis Analytics is pre-process the data with a Lambda function before it even hits your SQL that you've written in the app. So why would you want to do that? Well, think about Kinesis Data Analytics uses SQL, like I said. So SQL requires a schema, right? Select something from this table where these criteria are met. In order to have a nice schema, what if your data is not structured in a way that allows it to be kind of mapped to a schema? Imagine that it's unstructured input data, or it's a very complex data type. Maybe it's like a very nested JSON record. How do you map a very complex nested JSON to a SQL table, for an example? It's not that straightforward. So what you can do is use a Lambda function, and you can flatten out the data to do some amount of transformation from your original data source into a nice flat structure, so it makes it very easy to query against using SQL. So that's one reason why you might do some pre-processing. You might want to enrich the data. For example, perhaps some of the source data includes the IP address of whatever the data producer was. Maybe if it's a mobile phone, like earlier, you want to send in some information like an IP address from the mobile, but you want to do some geolocation. Well, you can enrich the data before it even reaches the SQL engine. You can enrich it with perhaps the city, state, country by creating a Lambda function that takes the IP address and does a geo-IP lookup and then enriches the data. And then now in your SQL, you can do things like group by state, group by city, group by country. You can get a lot of insights into your data because you've created an enriched data set before it even arrived in your processing engine. So that's pre-processing. It's not required. Kinesis Data Analytics will look at your source data, and it will create a schema based on what it sees, and it'll sample your data. We always recommend that if you go that path, that you go and you look at the schema that we created to make sure that it accurately reflects your data, because we're just taking a sample of the source data. However, if you do have complex or you want to enrich, then you can pre-process it with Lambda. So how do I write streaming SQL? It's pretty straightforward. If you've written SQL against a relational database, it's going to feel very similar with a few additional constructs. So this is streaming. So you see this statement here, create stream, calls per IP stream. Think of like a stream in this context as a temporary table for your streaming data. So imagine if I replaced that word stream with table, it's going to feel very much like a create table statement that you would write against a relational database. So now what this represents is kind of a temporary buffer in the Kinesis Analytics application that represents kind of a snapshot in time of the data that's streaming through my data source. And then how do I populate it? It's called a pump. So a pump is a continuously running insert statement that populates that stream that I just mentioned on the previous slide. So this pump, as you can see here, there's an insert statement that's inserting data into the stream called event timestamp. I wish I had named the two streams the same so it would correlate. But I think you get the point. So this insert statement is running continuously and populating the in-application stream. And then how do we aggregate that data? So remember, this stream, right, it's kind of unbounded. A stream of data, if I just said select count star from my stream of data where these criteria are met, Kinesis Analytics will fail on you. And why? Because it's a continuous stream. There's no time bound. You need to tell the system, for streaming data, I need to know something about like a period of time for which you want me to do that aggregation. And that's where Windows come in. So it's not, you can use Windows if you want, Microsoft Windows, but it's not Windows. There are actually multiple types, but the two primary types of windows that you would use in a streaming data application are sliding and tumbling. So a sliding window is basically the metric will be, or the aggregate will be calculated at the end of that window period. So imagine I said I wanted to have a 10-minute window. Every 10 minutes, the aggregation is run, and there's an output. So if I want to count how many times an event has occurred over this 10-minute window, the Kinesis Analytics application will look at the events, run its count aggregation, and then at the end of that window, I get a result. A sliding window is a little different. Sliding window is a record comes in, using a 10-minute window again. Every time a record comes in, I look at the previous 10 minutes from when I received that specific record, calculate the aggregate, and then have an output. So the difference is, for every input that I receive in a sliding window, there is an output. So if 100 records come in, there's 100 records that go out. Each aggregation is built on that sliding window, where with the tumbling window, it's just on that period. Every 10 minutes, there's an output. And you can have custom windows based on the number of rows. So you can say, I want to build a window based on the last 100 records I saw. That's possible as well. And then there is the ability to do some timestamp calculations. So things like row time. So when did Kinesis Analytics first insert the record into the application? When did the record, when was it received by Kinesis Analytics? And then the event time is typically a timestamp that you would include in your message itself. And so you can build your aggregations based on those timestamps to do aggregations based on the event time. When did it occur? When did it arrive? When was it first processed? So these timestamps can be used in your queries. And then you can combine them to help with late events. So in a distributed system, think about the fact that there might be hundreds of different devices or servers sending this streaming data. It's entirely possible that if I'm doing a tumbling window, which means every 5 minutes I want to do an aggregation, if a record arrived slightly late, maybe the data producer had it created an event at 4:59:59, and then it had a network blip, and it didn't actually get until our backend until 5:01 or something. It missed the window that it was supposed to be in. So you can combine these windows by using a combination of the event time and the row time to basically handle late arriving events. So some of the customers that are using Kinesis today, there's a lot of them. These are just a couple. A few names you probably noticed here, things like companies like Netflix and Lyft process a lot of data through Kinesis. And then the one that we're going to jump into in more detail is Singha. So I'll turn it over to Milan now, and he's going to come up here and talk about their use case, and it's all yours.
Thank you, Alan. Hey guys, my name is Milan. I'm a principal software engineer at Singha. Make sure this works. Okay, and what I do there is anything to do with the analytics infrastructure. It's a lot of fun. That said, let me jump right into our motivation. So Singha's motivation is to connect the world through games. But that comes with a challenge, and the challenge being, how do we exactly know if games are fun and social? Once people start playing these games, how do we know if we're actually connecting the world through games? And that's where analytics at Singha comes into play. It's a system that allows or enables games to submit game events, which can be used later on for processing and doing analysis on it to generate insights. And the key part there being we want to generate data-driven insights. So in my part of the presentation, I'm going to talk about these things. First, I'm going to talk about what game events are at Singha, specifically for Singha. I'm going to talk about when does Singha need a streaming solution that Alan just talked about. I'm also going to talk about when does Singha not need such a solution. And then I'll dive into the implementation details of how we went about to implement a data analytics system within our use case at Singha, along with how we implemented the monitoring of this system. Because it's a largely managed system, how do we make sure that it's doing what we think it should be doing? And then later on, we'll give ourselves a score. How did we do in our implementation? Did we do well? Did we meet our design goals? And then lastly, I'm going to talk about some best practices that we learned along the way while implementing this system. So what are game events at Singha? Imagine you're playing Words with Friends, the new Words with Friends. You just started that and downloaded it. When you launch it, hypothetically, it could generate these kinds of game events. You could generate a visit game event, which could tell us later on for analysis of daily active users. You could generate an install game event, which I'll talk about later on as a use case of how that can be useful. We can also start tracking your session duration in the game so that we can know whether or not you're engaged in the game and if you're liking it or not. Let's just say you start a game with a player, and that could generate some game events as well. You can generate a social game event there that you started a game. And let's just say you powered up and bought some power-ups in the game, and you want to track those goods, and so that could generate a goods game event. Or you can switch over to the messaging chat in the game and start messaging your player, and that could generate messages game event. And then another use case is message click. So let's just say you can click onto the word that you played, and you looked up the definition of the word in a dictionary in the game, and that could generate a message clicks game event. So these are all hypothetical, by the way. I'm not saying this is what we're doing, but this is just a ways to see the different ways that we could generate game events. So given that use case, those game events, you can send them to a traditional warehouse, as well as you could send them to a streaming system for more real-time analysis of the events that are being generated. So one use case is this. So let's just say me and my coworker Bharath are playing this new Words with Friends on the iMessage platform. And what we want to know, the PM on the Words team wants to know how hot is the game doing after it went live, after it went worldwide, how well it's doing. So the question that they want to answer is how many installs did the new Words with Friends game have on the iMessage platform in the last 10 minutes? How do you do that? To make that happen, we have to do a certain few things. For example, the game itself needs to generate an install game event. So in our case, what we do is the install game events are tracked through, like Alan said, the Kinesis data stream system, which helps a lot because that solution is integrated with other services that Amazon provides, and that made the integration with Amazon Kinesis data analytics product a lot simpler for us. And that data stream is also then sent to our data store in the back end. So I'll talk about that use case in a second. But here's a case when we don't actually need a streaming service. So to answer a question like this: what is the Words with Friends D7, day 7 installed date retention? And what that's saying is that from the moment that the user downloaded the game and started playing, which percentages of those users came back and started playing the game again on starting day 1, day 2, day 3, all the way to day 7. The only way we can know that is if we track user-level metrics. So we have to track each day that the user came and their presence was in our team, in our system, it was present, and then we could do analysis on that particular user. Well, for a streaming system, that's really difficult, not difficult, but really costly to do, because you don't want to do user-level metric tracking for everyone in your system. That's just going to blow up your system, right? And so that's not an ideal use case for a streaming processing service. Instead, you would use a traditional warehouse. Once the data is collected, you run some queries on a nightly basis and figure that out. So going back to our use case of installs, before we built that use case and the solution for it, we had a core set of design principles in mind that we wanted to implement in our system. So what are those principles? There's 8 things that we considered. First and foremost, we wanted to use a managed service. And this is the main reason to do this is because we didn't want to take on the operational burden of running services systems in-house. We wanted to let Amazon worry about those things. And then the other thing that we wanted to do is build a stateless design. And the reason for this is anything that's valuable, so in our case, our data, we didn't want to manage that. We wanted to store all that managed, all that user data that we generate. We wanted to store that in a managed service because it's a more reliable and they have the resources to do it. So we use a stateless design in that case. We also wanted to make sure that our pipeline was loosely decoupled, right? And so what that meant is that every subsystem in the pipeline did one thing really well. And that, what enables us to do later on is we could put in more sort of finer grainer monitoring around each of the subsystems, and we can scale horizontal or vertically really easy when we do that. The other thing we wanted to do is make sure that this new system that we come up with was extensible. And what I mean by that is that if a new use case came for streaming, that we wanted to do it, we didn't want to go back to the drawing board and re-engineer the whole pipeline. We wanted to make it extensible. So I'll talk about how we did that. The other thing we wanted to do is we wanted to empower our customers. So our game teams, whenever they wanted to use our service, we didn't want them to be blocked by us. They should be self-managed and self-serviced. And so we wanted to make sure that they could easily use the system without worrying about a lot of different technical details. And then obviously we wanted to make sure the system scaled well to our traffic patterns. So that was an important consideration. And then the last two, fault-tolerant performance system, I want to make sure that, especially in a streaming system, if there is a disruption or if there is some sort of issue with the system, that it gracefully handles that. And that becomes more important for us because if we're looking at things like installed data, and if there's a bleep on the system, we don't want to think that people stop playing our games, but there's actually a graceful way to handle that. So I'll talk about how we did that. So that said, this is the high-level implementation overview of that system. That's a lot of boxes, but it's really, most of it is all managed, right? And so on the left there, you see the data producers. That would be our game teams. They send data to Kinesis data streams using the Kinesis service. And then that data, and this is a box around Kinesis data analytics, which is the Lambda preprocessor gets. And that data is then massaged into a aggregation-friendly output, which I'll show you later on how I do that. Then Kinesis Data Analytics gets that data, and it actually does the aggregation and generates the aggregations that we care about, be it count, average, max, min, and so on. And then the output is then written out to another Kinesis data stream. And by doing that, it makes the system really extensible, because now we can use Lambda readers or any consumers of Kinesis to read that aggregated data to do whatever we want. In our case, what we did was we wrote Lambda readers that read from these Kinesis streams and glued that data back to the consumers that cared about that data by calling their APIs. So here's an example. Imagine there's a game out there called Game X, and they generate data like this, right? So they have a counter called GameX counter, and they give me a game ID called GameX ID. And they want the aggregation of this data be sent to a metric called GameX output metric. In our case, we use a convention of adding the type of aggregation we want. So that's the vertical CNT count at the end. So this particular game wants to generate aggregation of counts of how many GameX counters it gets in a minute. So how do we do that? Here's an example again. So imagine we played, Bharath and I played this game, and it generated this raw data stream on the top there you see. And what it has is the game ID, it has the timestamp of the record, and then it has the particular type of event that it generated. So in this case, it's GameX counter. It also generated a GameX message click event, which in our case we don't care about because we just want to. So we'll discard that row, and I'll show you how we do that. And we just want to aggregate the data of GameX counters. So after going through the Kinesis data stream system, data analytics system, we want the output to be what you see at the bottom there. That at the 39th minute, the count was 3. And at the 55th minute, the count was 1. So how do we do that? The key component to make that happen is the preprocessor, the Lambda preprocessors. So here's a diagram of what our preprocessor Lambda does. So we could do whatever we want in this Lambda. In our case, what we do is we take that raw input stream, and we transform it to be an aggregation-friendly input for the Kinesis data analytics. And then that is done through 3 functions, right? So first, because we retrieve data set from the Kinesis streams, we're getting the data in the Kinesis producer library formatted data, right? Which the Lambda or the Kinesis data analytics at that time didn't understand. So what we had to do is we had to parse that and kind of explode that into not to be a Kinesis producer library formatted batch. And then what we do is we would match records, data records, to relevant metrics. So by relevant, I mean metrics that game teams care about. Not all the data records, but the data records that they want to subscribe to, right? So we throw away stuff that we filter out the data that the game teams don't want and only keep the ones that they want. And then the third thing that our Lambda does is it maps the input data to an output metric taxonomy, or the schema that I showed you earlier. And sometimes that could be multiple metrics that we do that to. So going back to our example, of the raw entries that you saw, the CSV entries, now after going through the preprocessor, in our case, those raw entries are turned into these JSON blobs. And that's the schema that you see that we wrote our Kinesis data analytics SQL around to make it aggregation friendly. So what you see there is the time is its own key value. Then the source, the metric, which is the output that we care about. The detail in this case doesn't matter, but if people wanted to add other details to aggregate by, they could do that. And then the actual value for that particular row. So in this case, the value was 1. And then the next thing that we do is the SQL. So what does the SQL look like, right? So at a high level, the SQL does this, right? So the top yellow box is the preprocessor output. So that's where we transform the raw data to the taxonomy, output taxonomy. Then the next set of gray boxes is the SQL part. So our SQL is actually designed around 3 windows, and I'll talk to you guys about why we use 3 windows. So the first window is where we group by the row time, which is the timestamp that the Kinesis data analytics gets on arrival of the raw data. The record time, which is the event timestamp that Alan talked about earlier, and the source and the metric and the detail, which you saw in the previous slide. And then we use the floor SQL function, which the Kinesis data analytics system provides, to kind of normalize the times to the closest minute. And that's how we get rid of the seconds in the timestamp, because we want to do a minute-level aggregation. So the output of that is then sent to another tumbling window. And in there, we merge multiple input streams. So imagine if you have one particular game event that's of high volume, and you want to be able to keep up with that high volume. So Kinesis data analytics streams, what they provide is the ability to increase the input parallelism. And so when that happens, your input stream is then split into different streams. Then you need to basically merge them back in order to make some analysis around it. Because if you treated them separately, then your final output could be incorrect, right? Because one stream could have more counts than the other stream. So the second tumbling window we use to merge those multiple inputs, again, using by group by. And then the third window, which is where we use a sliding window, That's actually where we calculate the count, the sum, the average, the min, the max over a 10-minute sliding window. So why do we go with 10 minutes? Because we know that in our case, our data usually, on worst case scenario, takes 10 minutes to get through the pipeline. So we wanted to kind of amend that late arriving data by giving enough time. But usually, on average, it takes about 3 minutes. So 10 minutes is more than enough in our case. And then finally, the data of that aggregated values are written out to another Kinesis stream, which the consumers consume by using a Lambda. So going back to our example, what does that look like? So the data that after the first window of that tumbling window, this is what the data ends up looking like, right? So there you can see in green, the seconds have been normalized, right? So that's close. It's rounded off to the nearest minute. But here, what we really want is that the 39th minute and the 40th minute output, we want to merge them together because it's really within the minute boundary. And then the 55th minute can be its own output, which is fine. So how do we do that? And that's where the second tumbling window comes into, the third sliding window comes into play. So let me walk you through a scenario. I think this might be more telling of the different output that you can get using a tumbling window. So imagine that you have a system that produces 1,000 records, and it's within a minute, so from 12 to 12:01. So when it goes through processing, in the first minute, it gets 800 records. In the second minute, it gets 190. In the third minute, it gets 10. So what does this data look like when it goes through a tumbling window? So the output will look something like this, where at 12:01, you're going to get 800. At 12:02, you're going to get 190. And then at 12:03, you'll get 10. Right? And this isn't, so if we had this solution, then our consumers will need to be smarter and be more stateful because they'll need to aggregate all the outputs across all those minutes into coming up with the final 1,000 answer. So that wasn't desirable. The other issue with this is that if there's a disruption or if your Kinesis data analytics app needs to be restarted, what will happen is then the system might produce duplicate data. It will repeat the output. And so even if we had a stateful consumer, it's going to get a false aggregation value. So that wasn't quite what we were looking for. Now, what if you go through a sliding window, right? So with the sliding window, the data is kind of sliding, the window is kind of sliding. So the cardinality of this output is going to be really high. So for 1,000 input records, there's going to be 1,000 output records, and each time the aggregation is going to increase, right? And what we really want is the last one, which is the 12:03:32. Of 1,000 records, right? But what this means is now that our consumers need to consume a lot of data, right? Which again wasn't ideal. And so what we really wanted to do is use a multi-window chain approach, right? And we wanted to combine the cardinality reduction feature of a tumbling window with the summation feature of a sliding window and produce something like this. So at 12:01, it produces 800 records. At 12:02, it produces 990. And then at 12:03, it produces 1,000 records. And so that's manageable. It's small enough data stream, and the last value is the correct value, and it's not a lot of data. So that's what we want. So now in our solution, like I showed earlier, we're using 3 windows. And the tumbling windows is a 1-minute summation, or the group by is done by 1-minute windows. And then all of that data is fed into a sliding window, which is that SQL of window at the bottom that you see. And I'm told there's improvements on how we could do this better. But at the time when we did this, we used a floor function to do that. And today, you could use a step function. So now the final data output, the Kinesis data output, is what we want. So at the 39th minute, you get the count 3, which is what we wanted. The sum is also 3. And then the 55th minute gets the count 1. This is exactly what we wanted. So this is just with one particular metric that we wanted to aggregate. But what if a game team goes and adds another metric they want to aggregate by? We don't want to exactly go and restart our applications because that would disrupt the existing streaming aggregations that are occurring. And we didn't want to do that. So how do we achieve this? How do we achieve a non-disruptive updates implementation into our system? So what we did was then we created this little subsystem. So on the left, you see that bubble is of the customers or the game teams. What they do is they write into a metric, into an S3 file with the aggregation metric that they care about. Then our preprocessor periodically will read from that S3 bucket file. And then the Kinesis data analytics invokes the preprocessor. Whenever it invokes, it starts noticing that there's a new set of metrics that we need to start aggregating by. and everything just works after that, right? And so how do we get the metric from S3 into the preprocessor? So the only piece of managed hardware for this system that we have is our Jenkins build server. And so what our Lambda does is it actually makes a call to our Jenkins build box, which then generates the preprocessor metrics and pushes into S3, which then the preprocessor reads from. So this is a pretty nice and simple solution that worked out pretty well for us. So with that said, this is a system that works pretty well, but it's a largely managed system, mostly by Amazon. And so we wanted first make sure that our system is correct. So we wanted to measure correctness. We wanted to measure the completeness of our system, like is it getting all the data that it cares about, that we care about. And lastly, that the data is fresh enough, right? That there's no real lag in the system. So with the Kinesis data analytics system, you get a metric called millis behind latest, right? That's a CloudWatch metric that you get it. With this, you can tell if one of your Kinesis data analytics application is falling behind in reading the stream input that it's getting. That's good, and it's helpful, but it doesn't tell you if the data is complete, correct, or fresh. So this is where we implemented another monitoring system called the heartbeat monitoring. So the heartbeat monitoring is, going back to our high-level overview of our system, is a system that artificially generates game events every minute, 100 artificial game events every minute at 2 injection points in the system. So where you see there is that at the start of the pipeline, through the HTTP layer, we inject 100 records using a Lambda, and that we call tier 0 injector. And then another injector we put in that injects directly into the Kinesis data stream by passing the HTTP endpoints, which we call tier 1 injector. And I'll talk about why that was important when I give you the metrics that actually collected that. But the taxonomy that each of these injectors generate is slightly different because we needed to be able to compare the output between those 2 injectors later on. So what you see there is the kingdom is set to tier 0 for tier 0 injector and tier 1 for tier 1 injector. So here's an actual CloudWatch metric graph for these injectors. So what you see there is the tier 0 injector metrics. And there where you see is if we get 100 consistently for every minute, we're doing good. We're not losing data, and we're not duplicating data. That's doing well. But what you see here is there's a lot of spikes, right? And I'll talk about why we have a lot of spikes. But sometimes, like you see on March 12th, that there's a dip of data. And then there's immediately after that, there's a big spike right after, right? So what do we make of this, right? So what this tells us is 2 things. Or it could be 1 of 2 things. One is that the HTTP layer that we inject our data through is generating duplicate data through retries. And this is a common use case, especially if you have a mobile device generating data into a pipeline, given connectivity issues and whatnot. It'll do a lot of retries. Or the second thing is that our Kinesis and the Kinesis data analytics system is actually dropping data and duplicating data, right? So how do we know which one is it, right? And that's where the second heartbeat metric comes into play. This is the tier 1 heartbeat metric. And here, as you can see, on March 12th, there was no dip or spike for the same data set. So what that tells us is that this was our HTTP layer that was generating duplicate data. And so the other spikes that you see throughout the other days, that's more than 100, that shows that usually happens when we retry sending data to our Kinesis streams. And sometimes when there's a throughput issue or whatnot, we'll do a lot of retries. And sometimes the data will get through, sometimes it won't. And so we have to retry, and that's what the spikes are indicative of. So things are good. So this system monitoring system that we built, we felt really confident with our solution afterwards. OK, so now what's our scorecard? How do we do in our implementation? Going back to our design principles that we started out with, did we meet all of them, right? So a heart means that, yes, we met it. So let me walk through them really quick. So for managed service, yeah, so we used Lambdas, we used Kinesis Data Analytics, and we used Kinesis Data Streams to build this. The only managed service that we have is an in-house Jenkins job, which also, by the way, runs on ECS. So that made it really simple that we met that goal. Stateless design, we store all of our game events in Kinesis Data Streams, so we didn't have to worry about storing that data. Loosely coupled, as you saw, our input of our data is decoupled from the filtering of our data to the aggregation of our data to the output of our data, so that worked really well. The extensible system made just writing it to Kinesis streams, Kinesis data streams, made that our system was quite extensible. By using S3 as a way to collect the metrics that game teams want to Aggregate on, it's all controlled by them. We do have smarts built in. If there's a typo or something like that, we'll generate a nice email for our game team and let them know that, hey, there's a typo in your aggregation metrics. But now it's all automated, and it empowers the customers. So we weren't the blockers for that. And then the scalable system, again, just by subscribing and aggregating data that game teams care about, we made this system quite scalable. Instead of aggregating every single type of game event, we just aggregate the data the game teams care about. So that made the system scalable for us and reduced cost quite a bit. And then the last two, fault tolerant and performant, we completely rely on Amazon to help us do that, right? And so we expect that the Amazon system services are graceful when it comes to disruptions of their systems when things need to be rebooted. And they do it within our SLAs, which makes our system quite fault tolerant. And performant was just to be able to handle the amount of data that comes through the system. So we did pretty well. We were quite satisfied with the implementation. So what are some of the best practices in this solution that we learned through our building this system? 5 things, right? So first, we learned quickly that we don't need to over-engineer. Keep it simple. Keep only apply the use cases that we need to implement the use cases that we need to apply for right now, and then make it extensible later on, which we did. The second thing was take advantage of the exactly once semantics of the preprocessor Lambda. So lambdas by design can be invoked multiple times. They give you at least one semantics, which doesn't work for a streaming system. You don't want a bleep or a spike in your installed data stream when it wasn't actually your install. So what Kinesis Data Analytics promises is that even though the Lambda preprocessor could be invoked multiple times, the input of that data that it gets is going to be exactly one. So it deduplicates the data for us, which worked out pretty well for us. So take advantage of that. And the other thing you want to do is use the preprocessor to transform the data to be an aggregation-friendly format. So by doing that, it removes the need to restart your Kinesis Data Analytics or update the SQL every time there's a new metric you need to track. You just need to add configuration, and everything just works just fine. You don't need to update the SQL every time. So take advantage of the preprocessor in that way. And then also design with the consumers in mind, right? So we wanted to simplify the lives of our consumers. We don't want to have them implement stateful designs or re-implement the Kinesis client libraries again on their sides to retrieve the data. So in our case, we used Lambdas to just call their APIs and did all the heavy lifting for them. And last but not least, use an opt-in-based aggregation system. So again, this is referring to the case that don't aggregate everything, only aggregate the data that your customers care about, in our case, our game teams. OK, great. So that's everything. Thank you for that. And I guess now time for some questions, Alan? OK. So it looks like we have 11 minutes left.
So anyway, yeah, any questions you have for probably Milan more than me, but any questions, shout them out. Yep.
Yeah. What's the advantage of using Kinesis data streams over Kinesis Firehose?
So the question was, what's the advantage of using Kinesis data streams versus Kinesis data Firehose? So Kinesis data Firehose is primarily although it does have a streaming component is primarily a managed consumer for your stream. So it manages the buffering of the data and the delivery of your data to one of 4 destinations. It can be Splunk, Redshift, Elasticsearch, or S3. So if ultimately all you want to do is stream data in and deliver it to one of those 4 places, Firehose is a better solution. However, with data streams, it gives you the ability to have a custom streaming processor using AWS Lambda, using Spark Streaming, using Flink, any number of kind of open source or third-party tools, or our own library, which is the Kinesis client library, which you would run on EC2. So streams is like I want to write code to do custom processing of my streaming data, and Firehose is I have streaming data, and I largely want to just put it into one of these 4 destinations.
Yeah, and in our case, we were already in the Kinesis stream ecosystem, and we didn't want to bring in another system, so it made sense for us to continue using that ecosystem.
Anything else? Way in the back.
Can you do a breakdown on the things side of you said 10 minutes to 3 minutes is usually the lag you have in the pipeline. Can you do a breakdown? Do you have batching clients? Are you doing batching and compression before you commit to Kinesis, before you write to Kinesis, and then where is the lag?
Yeah, so most of our lag comes in that batching. So we use Fluent to write to Kinesis, which does macro batches for us. And then also when we read data from Kinesis to load into our consumers or to send to Vertica, sorry, not Vertica, but the Kinesis data streams, to get Kinesis data analytics stream, again, there's batching going on there as well. So that batching is what induces the delay. Sometimes it is the network connectivity from game teams that when they send the data, that it's in the transmission phase and it hasn't got to us quite yet. So typically on worst case scenarios, we see 10 minutes, but usually it's 3 minute.
And the micro batches are fixed, though, like is it 1 minute?
Yeah, so we do two types of micro batches. One is size-based and the other is time-based. So I think our micro batches are 6 megs, or I forget. So 6 megs big, and then the time is, I think, 10 minutes. Because there's some data streams that we get a lot of events, which will hit the size really quickly, and some that are really slow, which will hit the time quickly.
Any more? Oh, way over there on the right. I didn't hear. I don't know. I couldn't hear. Did you hear?
I didn't catch
Do you mind speaking up a little bit? Sorry, we don't have microphones yet.
Is there any use case around log streaming?
Does Singha, do they have cases of log streaming? Yeah, the question is, what's our story around log streaming, basically? Is that the question? Like, how would you stream existing logs? So there's a number of ways to do it. There's a lot of products like Fluenty that have agents that you could use to stream to a Kinesis stream or a Kinesis data Firehose. We have an open source library called the Kinesis Agent, which essentially tails existing log files. So if your system is already just logging to disk, you can stream those log records as streaming data by installing the Kinesis Agent and configuring it to tail those log files. And then every individual row that gets added to your log file will be a record that can get streamed to either Kinesis data streams or Kinesis data Firehose. So it's a nice solution if you've got an existing system, you don't want to have to introduce code changes to produce the data. You can just install an agent that'll run in the background and stream those records. Okay. Yeah.
I'm curious about your queries on data. How fast do you run? And do you expose the queries to the end user at all, or purely from a app panel?
That was for you, I think. Did
Sorry.
you hear it?
Can you repeat? Can you say that?
Do you mind speaking up? That was for Millen, right, on their use case? Yeah.
So I'm curious, do you, with your query latencies on your streaming data, do you ever expose that to an end user through an API, or is this something that you close internally for analytics?
The query latency?
Yeah, like how long does it take you to query
Oh. Right, so the question was, how long does it take for us to query the data that comes in through the streaming system, and then do we expose this to game teams in our case? Well, we do let them know what the SLAs are. So we tell them that if a game adds a new metric, within 10 minutes, they should start seeing their data. And if that doesn't happen, then we have internal CloudWatch alarms that tell us, like, hey, there's something wrong, way before they find out. So we try to address that as quickly as possible. But within the company, we let people, with all the game teams, know that this is the SLAs that are currently advertised. And then usually they're pretty happy about that, just letting them know, keeping that transparent with them keeps them happy, so they can build their use cases or reports around that, as opposed to letting them guess. So it's just being transparent with the game teams. Yeah.
Could you speak up? It's hard to hear
Can
up here.
you hear
Sorry,
me?
there's some noise up here. I'll tell you what, I'm going to do
How
this.
would it work with Amazon Athena? Is the question. How would Kinesis work with Amazon Athena? Delivering data to us.
Alan, you want to take this one?
Yeah, sure. So you would have to deliver that. So the question is, how does this integrate with Athena? Is that the basic question? Sorry, where are you? There you go. So essentially, Athena needs the data to live in S3, right? So what you would need to do is deliver this data, your streaming data, to S3. One popular way to do that would be to go through Kinesis Data Firehose and have it deliver the data to S3, and then, of course, configure Athena to use the data that got delivered there. You can build your own custom processor as well, either from data streams or data Firehose with Lambda if you want to do some transformation. But ultimately, you have to get the data into S3 so that Athena can leverage it.
Yeah.
How does the Kinesis-like system compare to something like a queuing system like SQS? For example, if I have a bunch of systems which generate events, and my job is to collect events from all these systems and deliver to consumers, I can have fast or slow consumers. What would you recommend, a Kinesis-like system or a queuing system?
Want me to take that one?
Sure.
So the question is, something like an SQS versus a Kinesis Data Streams. When would you use a streaming system versus a queuing system? Is that right? So there's a few differences. The biggest difference is with a Kinesis stream, with a data stream, you can have multiple consumers processing the same records concurrently in parallel at their own rate, right? So if that's your requirement, then a stream is really what you're after. With a queue, typically you're talking about, I put a message into a queue, and I want to have one consuming process pop the message off the queue and do something with it, and then the message is not available to other consumers, right? So that's one of the primary differences between like a queue and a stream. There's some others, but that's the big one.
To add to that, at Singha, what we do is the batches, once they're post-Kinesis, we actually queue them using SQS, and then we have consumers that run in ECS that retrieve data from that queue and load it to our warehouse, which is in Vertica. So for that, we use a queuing system. But for the streaming use case, we use Kinesis streams because that was an ecosystem that already existed.
And on the flip side of that, we have time, yes. So let's say you had a number of messages, but you wanted to scale your consumers based on the number of messages. So I've got one piece of work to do, but I want to do it in parallel. So I want to have dozens of servers all doing this same thing. Then a queue would be a good solution because you can scale your solution based on the number of messages in the queue, right? You can use the queue depth to determine, oh, okay, now I should add more workers, more consumers to do some work. But those would be doing the same thing as opposed to a stream where you have multiple consumers who might be doing different things in parallel. Anything else? Yeah.
Is there a limit as to how much or how many SQLs can run in the analytics?
Is there a limit to the number of SQLs that you can run in analytics? So there's a limit, which is what we call in-application streams. So if you remember when I was talking earlier, I was saying there's the statement that was create stream, and it looked a lot like a table. You can have 15, I believe. I think Ryan just left. 15 in-application streams is the maximum that you can have in a single Kinesis Analytics application. So depending on how you construct your SQL, you can have basically think about your input source, which is your data coming off of a Kinesis stream. You can sort of fan that out internally in your Kinesis Analytics application into potentially 15 different paths through your app, but that would be the limit. But your SQL can be, there is a limit, but it's kilobytes. I forget exactly what it is, but that would be a very large application if you met that limit, the number of K of your actual SQL code itself.
So what's the data retention policy from the stream? Let's say, for example, I have like 5 consumers, and I'm writing the data into the stream, and all the 5 consumers are consuming the data.
Mm-hmm.
What will happen? Will still the data will be retained in the stream until like the set period of time, like let's say 24 hours, or it's going to be like as soon as the 5 consumers are consuming the data will be gone?
Yeah, his question is about data retention in a Kinesis data stream. So in a Kinesis data stream, it doesn't matter how many times it's been consumed. It's purely based on the expiration of the stream. So by default, that's 24 hours. So a message will sit in the stream for 24 hours, whether it's consumed once or dozens of times, it doesn't matter. Once that 24-hour period has expired, then the data is gone. You can extend it to be up to 7 days. That's the maximum retention period you can set on a stream.
Yeah, and at Singha, this was quite useful for us because if we ever need to replay the data stream, the data is already there in Kinesis, and then we don't need to go to our archives to get it again and reload it. We just rerun our consumers with a different timestamp. Right, the question was, have we considered Kafka versus using Kinesis? So yeah, a couple of years ago, when we started to look into Kinesis, we did look at Kafka. Previous to that, we were using Scribe as our data transmission system. And Scribe, as you know, it's a dying tech, and it was something that Facebook wrote that is no longer maintained, had a lot of issues, so we need to get out of that. So the biggest thing that why we went with Kinesis is the fact that it's managed for us. With Kafka, we had to manage our own clusters, which we didn't want to really get into with what we wanted to focus on. We wanted to focus more on adding business value, not managing the service. So that's why we went with Kinesis. And which worked out pretty well because now we can take advantage of these other Kinesis compatible services like Kinesis Data Analytics to do our streaming use case. So. Right, so the question was, are we calculating the same metrics for historical data as well, or are you just doing that in real time, for real-time stuff? So it really depends on our consumer. So this is really just an aggregation engine that we use the Kinesis Data Analytics for. Once we send the data off to the consumers, we have a consumer that records that data in its own data store for graphing purposes and to show viewing purposes internally. So they'll keep track of historical data from the point we started sending them data. But any other analysis that like analysts or developers or game product managers want to do, they have two options. They can either set up a metric or they can go look at our warehouse, which has the raw data that's sitting there in Vertica.
So fancy metric X, they have to write something completely differently and calculate it in the historical system versus the system.
Right, so the question is, like, if you create a new metric and you wanted to validate that metric, yeah, you have to, we did the validation for them already, so they could trust it. But if they wanted to do, they can run the same query against our Vertica warehouse and get the same output to look at the output results.
But it's a separate query. You can't use the same query against Vertica.
Right, you couldn't use the Kinesis Data Analytics query. You need to understand the schema of your warehouse and write a query that translates.
Kinesis Analytics, I guess, might move more towards,
We're going to... Well, do you mind if we're getting kicked off? There's another session about to come in. We'll come back and answer your question.
Okay, thank you.